we're going to deal with common logarithms. If a logarithm has no base written, as you'll notice this first one, there's nothing written for a subscript. If there's no base written, it's assumed to be base 10. So keep that in mind. If you're missing a base, it's understood to be base 10. Your calculator uses base 10. The log button on your calculator, which is over here, is base 10. It's the only one your calculator does other than the natural logarithm, which we have not got to yet. So if you were asked to do log base 10, all you'd have to do is just hit the log button, type in 6 for log of 6. When you hit the log button, type in 6, your calculator will display this. For this one over here, there's no base written, so you go on your calculator log, type in 0.35, hit enter, and you get this one here. To solve these problems, since our variable's in the exponent, we can always use logarithms. We looked at some problems earlier in the chapter where we tried to get the same base on each side. But there's no way we can easily rewrite 62 so that it ends up being 5 to the power. So what we're going to do is we're going to use logarithms. I'm going to go ahead and apply a log to each side. But now that we have an exponent after a log, I can take that exponent and put it down in front. That's one of the properties of logarithms. We now have it written as x times something. To get rid of multiplying by the log of 5, all we have to do is divide the left side by log of 5, and then divide the right side by log of 5. So on the left side we get x, right side we get log of 62 over log of 5. That's your calculator ready form. So then you go ahead and you type that into your calculator to get the decimal approximation, and we will get this here. When you type it into your calculator, go log of 62, make sure you close the parenthesis, then you're going to hit divide, and then go log of 5. Similar approach over here. There's no easy way to rewrite 17 as 3 to a power. So we're going to use a log because our variable is an exponent. So we'll apply the common log to each side. Exponent after logarithm, put our exponent down in front. Then you have it written as x times something. So to get rid of the timesing by that log of 3, divide both sides by log of 3. And we get our calculator ready form here. Type that into your calculator, going log of 17, close the parenthesis, go divide by log of 3, and we get this. Similarly, it works when we're dealing with inequalities. Our variable's in our exponent, so we're going to take the log of each side. Then we're going to go ahead and take our exponents after our logs, put them down in front. Take this exponent, put it down in front, because that's the clog rule for properties of logarithms. But since we have a couple of terms here that we're putting down in front, we've got to have that in parentheses. Now, this log of 3 is just like a number, so we're going to take this and distribute it through to each one of these to get rid of the parentheses. And that's what we have down here. We're trying to solve it for x. To solve it for x, you need to make sure you have the x's on the same side. Right now we have it on both sides. So let's go ahead and subtract a 5 log 3 from each side. 5x log 3. So on the right side that disappears. On the left side you get your 7x log 2 minus your 5x log 3. Now, these are not like terms because they have different logarithms, so we can't combine them together. However, they both have x's, so let's go ahead and pull that x out. Factoring out that x, not doing anything to the right-hand side, we have this. We now have it written as x times something. So then to get x by itself, all you'd have to do is divide both sides here by the parentheses. So you divide both sides by the parentheses. When you divide both sides by the parentheses, you get just an x over here. Over here, you get this over your parentheses. But keep in mind, your inequality sign is going to switch. Why does it switch? Because what's in the parentheses ends up being a negative number. And you would not know that unless you get the decimal approximation of this on your calculator. When you type it into your calculator, you'd realize it was a negative number. Now, this is your calculator ready form. So you're going to type the whole top in, hit divide, and then you got to put the whole bottom in parentheses because there's more than one thing down here. And then you would get your decimal approximation. We don't have to be concerned about having negatives after logarithm here because we didn't start with logs in our original problem. So we'll go ahead and take a look at this problem over here. Similar thing, we're going to have to go ahead and apply a log to each side. Exponents after our log, so we'll be able to go ahead then and take our exponents down in front. Once again, we have more than one thing in our exponent over here, so that's got to be in parentheses. Then we've got to get rid of the parentheses, so we'll take our log 10, we'll distribute it through to the x, and we'll distribute it through to the 2. Now, since we're trying to solve it for x, we need to get x on the same side. So we're going to subtract an x log 10, subtract an x log 10 from both sides, and then we're going to get this. Once again, we cannot combine these two logs together right here because one has a 10 and one has a 5 after the log, so they're not like terms. But we do have an x in each one, so we can go ahead and pull that x out. So factor your x out. Now we need to go ahead and do some dividing. We're going to divide both sides by what's in our parentheses. When we do that, we end up getting an x on the left. In this case, our inequality sign does not switch. The only way you're going to know to switch your inequality sign is to check what you are dividing. We were dividing by this. If that ends up, when you type it into your calculator, to be a positive number, you don't switch your inequality sign. If you type this into your calculator and you get a negative number, then you're going to have to switch your inequality sign. So what we have right here is your calculator ready form. Then you want to go ahead, type that into your calculator, putting the whole top in parentheses, divided by, put the whole bottom in parentheses, and you will get this. Now, it is possible when you were working this out that you thought, oh, this right here simplifies because we have a base of 10. When you have a log base 10 of 10, it cancels out, leaving you only with the exponent. And so then you could have worked it out and got your calculator ready form to be this one here. But either way, you get the same decimal approximation. So let's go ahead and take a look at the change of base formula. The change of base formula allows you to go ahead and rewrite something into a different base. Typically, you're going to rewrite stuff into base 10 because that's what your calculator uses. So it says you go log base of anything of u. You could rewrite it as log base 10 of u. Since it's base 10, you don't write the 10. Over log base 10 of b. So the small subscript base goes on the bottom. What was after your log goes on the top. Since these are written as common logarithms, log base 10, you can type it into your calculator to get a decimal approximation. So we can do that one down here. You want to go log of what's after your log, as a common logarithm, over log of your base, which is log of a 2. These are both common logs, log base 10s. We'd type this into our calculator to get the decimal approximation. And then we would do that also over here. Go log of the 18 over log of the base, which is base 3. So it's log of 18 over log of 3, using your common log button on your calculator, typing it in to get this right here.